If I could use unequal size pixels in 2 dimensions, a lot of possibilities come up. For example, notice here the width of my pixels increases as I go from left to right, but so does the height. So pixels here are very small, very thin, but they are quite tall over here. Here, my pixel width increases, but the pixel height decreases. Here, my pixel width and height both first decrease and then increase. And here, the height increases and then decreases, whereas the width first decreases and then increases. In fact, as you can imagine, a lot of possibilities come up because we can independently control what happens on the width as well as on the height. But let's see how we are doing this. The key idea really is again going back to the for loop and making use of the counter variables. Now recall here we are making a grid, which means we have not one, but in fact two counter variables available, one for the row, one for the columns. Previously, to get fixed pixel width, we were using say 20 or 15, but both height and width were fixed. But now what we could do is that we can make the row pixel width, row index control the pixel width and the column index control the pixel height. And however, there's a small little catch here. Because of the way we have defined our function and the way we are creating the grid, recall that our function draws a rectangle by drawing 4 lines. It starts, let's say, from this corner. First line, second line, third line, and fourth line comes back here. But notice that it in fact goes upwards. Now, what I mean by that is if I, let's say, give 0, 0, 250, it's going to start from 0, 0. It's going to go 200 and then go up 50. So that's what I mean, the drawn rectangle being drawn upwards. But the way we have made our grid, in fact, it's going downwards. What I mean by that is that it starts from the top in the first row, then the second row is below that, third row is below that, and so on. To keep code simple, the easiest method is to also make our rectangle draw downwards. And the way we can do that quite easily is just using a negative number for height. Now, nothing to get alarmed here, it's just the way we have defined our function. Another definition, another way of creating the grid, perhaps you wouldn't need that, but the way we have defined it and the way we are doing the grid, we do need to make I mean, it just makes it simpler to keep the height negative, which means if I were to, for example, give 0, 0, 200 minus 50, notice my rectangle is now being drawn downwards. Now with this set, in fact, it's quite straightforward. It's almost the same as what we had done in 1 dimension, except that we are going to just basically use the column index to control the height of the first row, then the second row, the third row, and so on and so forth. So we draw one row, we move down exactly by the height, move down exactly by the height, and so on and so forth. So I have here the code which draws out the regular 2 by 2 grid with equal size pixels. My pixel size is 20 by 20. But like I said, I could use 3 methods. I could use the range, I could use a function of the column or row index, or I could use a list. So let's see some examples. Let's say I say instead of using range n calls, I do, for example, say range 1, 40, and say 2. Now again, this is going to go 1, 3, 5, 7, and so on and so forth. And let's say on rows, I do again 1, 40, and 2. Now, what I would do is that I want to draw every pixel with the width controlled by JJ, because JJ is in that range, and the height controlled by KK. But recall, I want to make my KK negative. So I'll just make KK as minus KK. And also, since the width is JJ, so instead of 20, I make it JJ. And since the height is KK, I make this 20 as KK. Now, when I run this code, see what happens. My width of the pixels keeps increasing as well as the height keeps increasing. Let's say I reversed a little bit here. I say instead of 142, let's say I did say for example I did 39, 0, and say -1. Now this range is going to give me a sequence 39, 30. Well, I want to do -2, so I want to do 39, 37, 35, and so on and so forth. Now in this case, notice my width keeps decreasing, but the height keeps increasing, as you can imagine, because JJ here is controlling the width of these pixels, and JJ goes through this range, and hence width keeps decreasing. Now let's say I make use of two lists, one for the widths and one for the heights. Now for now, I'm just going to set heights, heights equal to widths. What I want to say here, what I mean here is that this list will control how the pixel widths will be on every row, and this heights will control the height of every row. So instead of KK going in this range, I say KK should go in the range length of say heights, and for JJ I will say go in the range of length of say widths, and instead of JJ I'll want my rectangles to follow this width JJ, just like we have done in one dimension. Instead of KK I'll say heights say KK. Now having done this, I must make sure that my my the x value changes by widths JJ, my y value changes by heights say KK. Now if I do this and I run this code, notice what's going on here. My list here was such that it started with a large number and it went down, then increased again. And since height is equal to width, I see that first the width decreases, then increases. Likewise, the height decreases and then increases. Now, there is nothing sacrosanct about this list. You can, in fact, try many possibilities here. The only thing that I've taken care of and kind of maintains the shape of the grid is that these numbers all add up to 400. But you can very well shuffle this around and create new lists. Let's take one more example where I do not do this. Instead, I have another list for heights, and heights, notice, first increases and then decreases. Now when I run this code, my widths first decrease and then increase, my height first increases and then decreases. And really that's happening because the list's widths and heights can be controlled independently. Now you can imagine a lot of possibilities come up with this. Be creative, enjoy this whole process. Take care. Thank you so much. Bye bye.